All right, method 2 of subtracting integers, we're going to call rewrite and add. Okay, so I want you to think back to the bell work that you did just now, or earlier today, and here was the question. It said, what is 3 minus 10, and what is 3 plus negative 10? And then there were two questions below. It said, what do you notice about the problems, and what do you notice about the solutions? Okay, so you probably noticed with the problems that we have the same numbers, 3 and 10, 3 and 10. What's different here in the middle is this is a subtraction sign, and this is adding a negative. When you worked out those problems, 3 minus 10, if we did that on a number line, if we look up here, we start at 3, and we're subtracting, so we're going to go 10 to the left. 1, 2, 3, 4, 5, 6, 7. We need to go 3 more, so negative 5, negative 6, negative 7. Okay? We also know how to solve 3 plus negative 10. We have 3 different methods we could learn, or we could solve this that we have learned. Okay, so whatever method works for you, but for me, I would look and see that I have 3 positives and 10 negatives. So I would end up canceling out 3 pairs of opposites, and I would end up with negative 7. So in your conversations with your bell work, you should have realized that the solutions were the same. Okay, and that leads us to our method 2 of subtracting integers, which is rewrite and add. Here's the good news, ladies and gentlemen. You don't have to memorize any new sets of rules. All you're going to do is add one thing to the beginning of what you've already learned. So on page 7 of your notebooks last week, you learned how to add integers using the same sign or different sign rules. We're going to use those exact same rules to solve subtraction problems. The only thing we're going to do differently is before we solve the problem, we're actually going to turn it into an addition problem. So every single time we come across a subtraction problem, we are going to rewrite the problem to an addition problem. Okay? So our first step is to rewrite the problem to create an equal addition problem or an equivalent addition problem. Okay, so just like this bell work problem, 3 minus 10 and 3 plus negative 10 are going to give us the same solution. That works every single time. We can actually rewrite every subtraction problem to be an addition problem as long as we do it correctly. Okay, so let's look at an example. Let's say we're trying to solve negative 6 minus 7. Okay, so here's what we do when we are rewriting the problem. We're going to keep our negative 6 the same. So this stays. Okay, so first number stays. I'm going to write that over here so I don't forget. We don't change anything about it. Okay, so we just rewrite it. Then we're going to change our subtraction sign to addition. Okay, so our subtraction sign becomes addition. We can do that as long as we do this next part, which is change 7 to its opposite. So the opposite of 7 is negative 7. Okay, so our very first step is to rewrite the problem. to create an equal or equivalent addition problem. So our first number always stays the same. We leave it alone. Our subtraction sign becomes an addition sign, and our second number changes to its opposite. Okay? So positive 7 becomes negative 7. Then we follow addition rules. Okay? So we're going to go back to those rules from page 7. If signs are the same, add and keep the sign. If signs are different, subtract and keep the sign of the greater number. So in this case, we have a problem where the signs are the same. So we're going to add those two numbers together to get 13 and keep the sign the same to get a solution of negative 13. So negative 6 minus 7 is negative 13. Which again, we always like to think of the reasonableness of our answers, and it totally makes sense because if I owe someone $6 and then I borrow $7 more, I now owe them 13. Let's do 2 more examples before we move on. Let's say we're trying to solve 10 minus 14. You might say, but Miss Livingood, those are both positive numbers. Why would I even mess with that? Well, the second number is greater. So we're going to follow these rules over here. We're going to rewrite the problem to create an equal addition problem. Our first number stays the same, so our 10 stays positive. Our subtraction becomes addition. And our second number changes to its opposite. 10 plus negative 14. I have different signs. When I have different signs, I subtract. 14 minus 10 is 4. And I keep the sign of the number with the greater absolute value. So 14 is greater than 10. 14 is negative. So my solution is negative 4. If I were to solve this problem on a number line, I would start at 10. And I would go backwards 14. And I would end up at negative 4. Let's do one more. Negative 3 minus negative 2. That's a whole lot of negatives in there. So let's get rid of some of them. We're going to rewrite the problem to create an equal addition problem. Our first number stays the same. Negative 3 does not change. Our second number, our subtraction becomes addition. Our second number changes to its opposite. The opposite of negative 2 is positive 2. Once we get through that step, ladies and gentlemen, for some people it helps to just cover up that first problem because you're no longer even looking at that problem. You're now solving this problem because this is an equal problem or equivalent problem to the one you were attempting to solve. We have an addition problem with different signs. Different signs, we subtract the numbers. So 3 minus 2 gives us 1. Different signs, we find the difference and then keep the sign of the number with the greater absolute value. 3 is greater than 2, so our solution stays negative. Okay, so we rewrite the problem to an equivalent problem. Our first number stays the same. Our subtraction becomes addition. Our second number becomes its opposite. And then we flip back over here and follow these 2 rules.